Hello friends, welcome to a new episode of I Square. So far we have learned about real numbers. In the very first class we learned about Euclid's division lemma, Euclid's division algorithm, how to find HCF and LCM, etc. And in the second class we learned about irrational numbers, how we can prove a number is irrational and how we can identify a number is irrational or not. And in the third class or in the last class we learned about decimal numbers or decimal expansion. Of course, in the first sentence itself the class began with saying that a decimal number has two possibilities: either it can terminate or it can not terminating repeating. Okay, now we shall check how we can identify numbers which have terminating decimal expansion as well as numbers which have not terminating decimal expansion, whether it is rational or irrational, and so on. Okay, now we shall move to the exercise questions. Exercise 1.4, first question. Without actual multiplication, we are asked to find whether these rational numbers have terminating decimal expansion or not terminating decimal expansion. Certain questions are missed here just because you can easily do that questions if you understand this process very well. So we shall begin. First question, 13 by 3125. We are asked to ask that without performing actual multiplication, we should identify whether this rational number has a terminating decimal expansion or a not terminating decimal expansion. We learnt in the last class that any rational number is of the form p by q has a terminating decimal expansion if and only if its denominator is of the form 2 raised to m into 5 raised to n. See, if a rational number's denominator is of the form 2 raised to m into 5 raised to n, then definitely its decimal expansion will terminate. If you have this result in your mind, it is easy for you to do all these problems very simply. Okay, we shall check it out. So, the first question, 13 by 3125. It is equal to 13 by 5 raised to 5. How we can get this 5 raised to 5? Because the prime number factorization of this number equal to 5 raised to 5. If you find any difficulty in calculating this all at once, just do this process. Divide this by 5 and again by 5 and so on. Whenever we divide a composite number by its prime factors over and over again, we will get the prime factorization of that number. That was discussed in the very first class of this section, right? So we have 3125 equal to 5 raised to 5. So this number is equal to this form, right? And see that the denominator is of the form 2 raised to m into 5 raised to n. Since we have only 5 raised to 5 and it is of the form 2 raised to m into 5 raised to n. Students, always remember that 2 raised to m into 5 raised to n. When m equal to 0, it will become 2 raised to 0 into 5 raised to n equal to 5 raised to n itself. That is, when m equal to 0, we can see only 5 term of 5 in the denominator. When n is equal to 0, it will go vanishes and we can see only the power of 2, right? When m and n not equal to 0, it will express 2 raised to m into 5 raised to n form. Okay. So the denominator here, the denominator of this fraction is of the form 2 raised to m into 5 raised to n, since we have only 5 raised to 5. Clear? So by our previous result, this will have a terminating decimal expansion. Clear? Now coming to the next one, 17 by 8. We know that 8 is nothing but 2 cube, or the prime factorization of 8 is equal to 2 cube. See, we don't have anything to cancel here, so this is the simplest p by q form, and 2 cube is of the form 2 raised to m into 5 raised to n. Since when n is equal to 0, this term vanishes and we can have only 2 raised to m. So 2 cube is of the form 2 raised to m into 5 raised to n, and so by the previous result, this term will also have a terminating decimal expansion. Now we shall move to the third question. See, in the third question, we have a 7 raised to 5 in the denominator and we don't have anything to cancel. So we know that A rational number will have a terminating decimal expansion if and only if its denominator must be of the form 2 raised to m into 5 raised to n. But we have a 7 raised to something here. So this will not have a terminating decimal expansion. Now the last question. 6 by 15. We know that 6 by 15 can be represented as 2 into 3. Okay. 6 equal to 2 into 3. Now 15 equal to 5 into 3. And we can cancel 3. After all the cancellation, the simplest form is 2 by 5. So 6 by 15 is nothing but 2 by 5. And the denominator here is also of the form 2 raised to m into 5 raised to n. Okay. So this also has a terminating decimal expansion. See, we found that 3 among these 4 numbers have terminating decimal expansion without doing actual multiplication. Right? Is it simple? So there is 2 more examples in the question in this section. 64 by 455, 15 by 1600, etc. And you can do it by yourself if you understand this concept very clearly. Now, shall we move to the next question? Okay. Question number 2 of exercise 1.4. We are asked to write down the decimal expansions of those rational numbers in question 1 above which have the terminating decimal expansion. In the previous example, we have shown that these 3 numbers have a terminating decimal expansion, and in this exercise we are asked to find the decimal expansion. So now we are going to, without actually, if we can divide it and find the decimal expansion. Of course it is possible, but it is a time consuming process and we are doing it by a small trick. First question, equal to 13 by 5 raised to 5. Since the decimal expansion of 13 by 3125 can be found only after by making the denominator to a power of 10. It is easy and more time saving rather than going for a actual division. Okay, so we have 3125 is nothing but 5 raised to 5. How? Because when we divide or when we calculate the prime number factorization of 3125, we can easily see that 3125 is nothing but 5 raised to 5. Now we are going to multiply the numerator and denominator of this fraction by 2 raised to 5. Why? Because we have already available with 5 raised to 5. If we multiply the entire fraction with 2 raised to 5, then the denominator will be nothing but 2 raised to 5 into 5 raised to 5, which is 10 raised to 5, right? So we have into 2 raised to 5. We multiplied the denominator as well as the numerator by 2 raised to 5. It is equal to 13 into 2 raised to 5 divided by 10 raised to 5. Right, 10 raised to 5 equal to 13 into 2 raised to 5 is nothing but 32 divided by 10 raised to 5 is nothing but 1 lakh. So we get 13 into 32 divided by 1 lakh. It is equal to 416 divided by 1 lakh. It is equal to, see, we have 5 zeros, right? 5 zeros in the denominator. So in order to find the actual decimal number, it is enough to transform the decimal point from here to 5 decimal places to the left. So we have 0.00416 because we transformed 5 points to the left. Is it clear? Now we shall look into the next question. 17 by 8. We have 17 by 8 is nothing but 17 by 2 cube. Always remember that whenever we want to find the decimal expansion of a rational number where the denominator is of the form p by q, we should transform the denominator into the form 2 raised to m into 5 raised to n. Now here it is 8. When we factorize it into the prime factors, we get it is equal to 2 cube. Right? Now we are going to multiply the numerator and the denominator by 5 cube. So we have 17 by 2 cube into 5 cube divided by 5 cube equal to 17 into 125 divided by 10 cube, right? So it is equal to 17 into 125 is nothing but 2125 divided by 1000. It is equal to 2.125. Since the denominator has 3 zeros, so in order to find the actual number, it is only required to put 3 decimal places to the left. So we put 3 decimal places to the left to get the final answer as 2.125. Is it clear? Now we shall move to the next question. The next question is nothing but 6 by 15. We know that 6 is equal to 2 into 3 and 15 equal to 5 into 3, and 3 cancels, and 6 by 15 is nothing but 2 by 5. Now we have to multiply the denominator and numerator with 2, because always keep in mind that we always want, in order to find the decimal expression of any fraction without actual multiplication, using this trick we have to make the denominator a power of 10 if it is possible. So here it is possible. Just multiply the numerator and the denominator with what? 2. Since 2 into 5 equal to 10, so it will become 4 by 10, and the final answer equal to 0.4. So we found the decimal expansion of each of these numbers. Recollect that in the first exercise we proved that this decimal expansion of all these numbers will be terminating, and in this example we found out those decimal expansion. See, all the decimal expansion terminates. It's clear. Now we shall move to the next question. The next question, the example 3 of exercise 1.4. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? We shall look into the first question. 43.12345678 43.12345678. So we should check at first whether this has a terminating decimal expansion or not. If it is terminating, we should comment on the denominator of that fraction. Okay. See, in order to make this into a perfect number without any decimal places, or we should, if we needed to transform this point to this point, see, there is 9 digits, right? So we have to multiply and divide by 10 raised to 9, so that 10 zeros will come and this point will transform 9 times to the right. So we get 43.12345689 into 10 raised to 9 divided by 10 raised to 9. See, we multiplied and divided with 10 raised to 9. 10 raised to 9 is actually what? 1, put 1 and put 10 zeros like this. 9 zeros like this. Okay. So that's what 10 raised to 9, 10 square equal to 100, 10 cube equal to 1000. Similarly, 10 raised to 9 is something with 1 and 9 zeros. Okay. So we get like this. And when we multiply these two terms, what will happen? The point will shift from here to here, since 10 raised to 9 has 9 zeros. Therefore, it will be equal to 43, 1, 2, 3, 4, 5, 6, 7. Sorry, there is 7, 8, 9 divided by 10 raised to 9. Now in the denominator has 10 raised to 9. 10 is nothing but 2 into 5. So it will be equal to 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 2 raised to 9 into 5 raised to 9. See, the denominator is of the form 2 raised to m into 5 raised to n. Hence, this decimal expansion is terminating, as well as the denominator, when it is represented in the form of p by q, is of the form 2 raised to 9 into 5 raised to 9. Clear? Very simple example. It is good if you can work out or figure out more examples from other textbooks or guides. If you have any doubt, comment in the section. Now we shall move to the next question. The second question of example 3. 0.120, 1200, 120000, 120000, etc. This is the question. So we have to check whether this is a terminating rational number or non-terminating rational number, or whether it is a rational number or not. We said in the first class that, or in the beginning of this section, that whenever a number is a rational number, then it has only two possibilities. Either it has a terminating decimal expansion, or it has a non-terminating repeating decimal expansion. That is, the digit will repeat after a finite section. See, here it doesn't happen. After first we got 120, then we got 1200, then we got 12000, and this goes on like that, and the digits are not repeating actually. A particular progression is repeating. If and only if the digits are repeating, then only we can say that the number is a rational number. So definitely this number is not a rational number, because actually here the digits are not repeating. Actually this part of it is getting repeating, and the digits are not getting really repeated. So this is not a rational number. Okay, so we shall move to the next question. So the next question is the third one of the same example, 43.123456789 bar. See, you can see a bar in the question. What does that bar means? The bar means this number is nothing but actually 43.123456789 123 4 5 6 7 8 9 etc. See, after these digits, the digits will repeat like this, then again this will come like this, and so on. It will non-terminating, but the digits are repeating like this. Now we have to show that this is a non-terminating decimal expansion, so definitely this is a rational number, and we have to show that the denominator of this rational number when expressed in the form of p by q is not of the form 2 raised to m into 5 raised to n. We should comment on the denominator of the rational number. Evidently this is a rational number because it has a non-terminating decimal expansion as well as the digits are repeating. After this it will repeat. Okay, so the bar means a repeating digital number. After this section the same set will repeat and so on like that. Is it clear? So we shall look how we can prove that. First of all, we can represent this number as x. So x is equal to nothing but 43.123456789 bar. Okay. Now we are going to multiply this x with 10 raised to 9 on both sides. So 10 raised to 9 x is equal to 43.123456789 bar. See, actually bar means after this the again same set will repeat like that. When we multiplied both sides with 10 raised to 9, this side will be 10 raised to 9x, this side will be transform this point to 9 places to the right, and the point will come like this. So clear, this is the steps of this problem. Just remember these steps. We multiplied with 10 raised to 9. Why we picked 10 raised to 9? Because the decimal expansion after the decimal point contains 9 digits and repeated after every 9 digits. Okay, so we took 10 raised to 9. Now we are going to, this is equation number 1 and this is equation number 2. Equation number 2 minus equation number 1. Okay, equation number 2 minus equation number 1. What we will get? 10 raised to 9x minus x. It will be 999. Is it true? If instead of 10 raised to 9, suppose that 10 square x minus x equal to 100x minus x equal to 99x, right? What about 10 cube x minus x equal to 1000x minus x equal to 999x. So whenever 10 raised to 9 x minus x, we will have 9 9s into x in the left hand side equal to, how we can evaluate that? This is a difference, so we can find the difference directly. 43 point this and we should subtract this from this. So we have, listen very carefully, this is very important. Per minus, this is subtracting 43 point. See, when we subtract, the number after the point will get 0 point. When we have from 9, we subtract 3 will give 6, from 8 we minus 4 will give 4, then again same. So the answer will be 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6. When we subtracted, look into the subtraction. This minus this will be 0, 9 minus 3 will be 6, 8 minus 4 will be 4, and the rest digits will just transform easily, and we get 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6.0. So we will get like this. Therefore, x is equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6 divided by 999. Clear? So the denominator is of the form 999, which is not of the form 2 raised to m into 5 raised to n. It is not of the form 2 raised to m into 5 raised to n. See, whenever the rational number is non-terminating, the denominator will not be of the form 2 raised to m into 5 raised to n. So always keep in mind that whenever a rational number has a repeating decimal expansion, its denominator will definitely of the form 2 raised to m into 5 raised to n. And whenever the denominator is not of the form 2 raised to m into 5 raised to n, then the rational number will be non-terminating definitely. So whenever we can identify a rational number with denominator is of the form 2 raised to m into 5 raised to n, you can always assure that the rational number will terminate on division. If the denominator is not of the form 2 raised to m into 5 raised to n, you can easily say that the denominator will not, the decimal expansion will not terminate if we divide. For example, consider 1 by 7. The denominator is not of the form 2 raised to 7 into, 2 raised to m into 5 raised to n, right? So it will not terminate if we divide 1 by 7. It will continue and continue like that. Clear? So I hope you understood the concepts very clearly. If you have any doubt regarding any question from this chapter, you can comment it on the comment section, or you can Instagram us. So we will rectify your doubts. Thanks for watching. Stay tuned for the next video. Thank you.